First part of the lesson was on conversions, converting units. So pause this slide and just have a quick go at what you think these answers might be. And let's see if you've got them correct. If you did get these correct, then really well done. They're not obvious questions at all, and they can take a little bit of thought. If you didn't get them correct, I'm going to talk to you now about how to convert squared units and cubed units. So first of all, let's have a look at some squared units. So for example, I want to change centimetre squared to millimetre squared or vice versa. I know 1 centimetre is 10 millimetres, so I would always draw a picture of a square to start off with. Label the sides 1 centimetre. Now the area of that square has to be 1 centimetre squared. I'm now going to draw the exact same square, the exact same size, but label the size with 10 millimetres instead. We can then see that the area of this square must be 100 millimetres squared. So these are exactly the same size, and we have our conversion that 1 centimetre squared is 100 millimetres squared. Suppose I want to do kilometres squared and metres squared. Do exactly the same thing. Imagine a square, label the sides 1 kilometre and 1 kilometre, and then draw the same size square with the side lengths labelled in metres. And the standard conversion I'm using is 1 kilometre is 1,000 metres. From this picture, I can see that the area of this square in metres is 1,000 times 1,000, which is 1 million metres squared. It's not immediately obvious. We get our conversion that 1 kilometre squared is 1 million metres squared. And of course, we can do the same thing for metres to centimetres squared, and we get 1 metre squared is 10,000 centimetres squared. Now, I don't recommend that you learn these conversions in red. It's sufficient to just learn to use what you already know up here and just draw these little diagrams just to check your conversions each time. We can use the same approach when we're converting cubed units, but this time we're just going to draw 1 centimetre cubed and then relabel the sides. I can then see from my picture that 1 centimetre cubed must be 10 times 10 times 10 millimetres cubed, 1,000 millimetres cubed. Pause the video and see if you can work out the next two conversions, metres cubed to centimetres cubed and kilometres cubed to metres cubed. And hopefully you get these answers. I now go back and review some of these questions that you were just looking at before. Once I've got my conversions that I've written in red here, I can answer the others pretty easily. So if I'm going from millimetres squared to centimetres squared, my conversion is here. 100 millimetres squared is 1 centimetre squared, so 500 millimetres squared must be 5 centimetres squared. The next one, I'm going from centimetre squared to millimetre squared, so I'm going back the other way. And I can just look at the number here. To get from 1 to 100, I times by 100. So centimetre squared to millimetre squared, times by 100, and here I would have 350. My next one, kilometre squared to metre squared, I'm down in this conversion. And here to get from kilometres, from this 1 to that number, I times by 1 million. So timesing this by 1 million, move it 6 places, that decimal, so you get a 3 and then 5 zeros, you get 300,000 metres squared. Again, with all of these conversions in red, I wouldn't learn those at all, just use your basic knowledge you've got and sketch a picture every time. Now have a go at these questions or a selection of them, pause the video, and then when you're ready, restart, and the answers are here. The rest of the lesson is all on rounding, truncating, bounds and error intervals. I've attached some links to some Dr. Frost videos that explain that. So have a look at those, have a go at the Dr. Frost homework questions, see how you get on. If you're quite happy with those, you could also then look at, come back to this video. We're now just in 5 minutes into this video, and you could skip to the following questions, which were exam questions we covered in class. So here was the first exam question. Pause it and have a go. And then the answers are on the following slide. And this is the exam mark scheme. You're looking at the lower bound because you want to be absolutely sure it's not going to break. So you're going to assume it would break at the first opportunity. And then you want the upper bound of the crates because you're going to assume that they're the heaviest they can be. So you want to be absolutely safe on this one. Next exam question is this one. Pause the video. And then here's the mark scheme. You need to be showing your upper and lower bounds, your upper bounds of the coffee, your lower bound of the cup, your upper bound of the milk, times by 2. And then some logic to your argument. So a response to the question, will Beryl's cup ever overflow? And then there's an exam mark for your working neatly set out.